Chemistry students, today we are learning about activity series. Yep, this is going to be the last thing that we need to learn in chapter 8 is activity series. Okay, everything that you have learned this chapter is going to be applied here and then some. Now first things first, I'm going to tell you some things that you need to have out. Alright, so once I tell you these things, pause the video and then get these things out. First thing is get your textbook and go to page 286. I think that's the page number, and then have the activity series in front of you. Alright, secondly, be looking at that worksheet that I gave you on Google Classroom. That way you can have it in front of you. Alright, and after that you might want to have a periodic table nearby for those of you that are periodic table impaired. Okay, so alright, now you got all that stuff. Perfect. So I'm going to flip this camera around and I'm going to start talking about activity series, okay? Alright, so here we go. And rotate this so it looks normal. Alright, so these are some notes I have for you to kind of look at and we will discuss with you, okay? I know what I'm trying to do here. I hope you can read that. I've kind of left copies of this on the Google Classroom where it says activity series notes, and so feel free to look through these. Alright, but we're going to kind of look at the activity series and we're going to discuss these things right here. Something about single replacement, synthesis, and decomposition, and these rules. And then let me draw a line here, and then I'm going to go through some examples. These are the first 6 examples that occur on your worksheet, okay? Alright, so first things first, I want to pull this thing off to the side. Look at your notes. Alright, look at your notes, because I'm going to pull this off. I'm actually going to get the chemistry textbook that I have here at the house. Alright, if I can set it up here without it falling off so that you guys can somewhat see it. Alright, so I know it's pretty difficult to read, but hopefully you have yours and you're kind of following along. So here's how an activity series works. The things at the top, so lithium, are the most reactive, and the things towards the bottom are the least reactive, gold. Well, that makes sense. I mean, we make jewelry out of gold, and so we wouldn't want gold, like my ring, to be reactive. I mean, it'd be painful to wear my wedding ring. So, or earrings or anything else. And then you can see right above that's platinum and silver. And by the way, this is a partial activity series. This is not a complete one. This is just the one we're going to use to kind of get an idea of how things work on an activity series. All right. So what you're going to do is, up until now, here's how we started the chapter. We wrote and balanced equations. Then we took it a step further and we did synthesis, decomposition, single replacement, double replacement, and combustion reactions, and we actually finished those. You would get half the equation, we'd finish the other half, and then we'd balance that out. Well, now what we're going to do is we're going to get half the equation, and then we're going to predict whether or not that reaction occurs using this activity series. Now, for those of you that are like, Foster, are you going to make us memorize that? The answer is no. I'm going to give this to you on the test. But anything that I give in addition and is not on here, you need to have memorized. All right. So you're going to see me kind of make marks on here that are probably already marked on yours in your textbook, but you're going to see me make marks on here. So first things first, in a reaction, anything above is going to be able to displace or replace anything below it. All right, so in a reaction, lithium is going to replace any element that is underneath it, all the way down here to gold. Now this over here, this is just an activity series for the halogens, and they're just anything above replaces anything below. So it's obvious fluorine's at the top because it can replace any of these that are down below it. And so I'm going to kind of illustrate that as we go through examples. We're just going to use this activity series. Alright, so what you want to do is you just kind of want to look at these groups as we go down. The first group says reacts with cold water and acids replacing hydrogen, also reacts with oxygen forming oxide. So what we have is, and these are, by the way, all single replacement. There's no double replacement reactions going on here. Double replacement is actually going to be like a solubility chart, and we'll get into that when we talk about solutions. Alright, So reacts with cold water and acid, and it's going to bump out hydrogen. Okay, and also this second line is a synthesis reaction. So all of these will react with oxygen to form some kind of an oxide. Okay, so we go down to this next group, and we can see there's some slight differences. All right, it says react with steam. That's a big difference. So it's no longer cold water. Now magnesium through cadmium, they have to have steam. So you're going to be looking for a little G next to that H2O, not cold water. They still react with acids and replace hydrogen. They still form oxide. So they still do synthesis reactions when it's oxygen. This third group, let's see what's changed again. Do not react with water. So water's out. No more water. So if any of these drop in water, nothing happens. Right? If we drop a chunk of cobalt in water, nobody has to wear goggles, nobody has to stand back, nobody has to call their parents and say why they lost an eye. Nothing happens. If you take a nickel and you drop it in water, you don't have to run and jump behind the nearest bush. Nothing happens. So nothing with water. They will react with acids, replacing hydrogen. So you have to be able to recognize acids, okay? All right, still going to do synthesis reactions. These things will probably do what we call tarnishing. They'll do mild reactions with oxygen and they'll form oxides. All right, so we've you can see we're getting less reactive as we go down. What's going to happen with this last group? Well, this last group, will it react with acids? No. Will it react with water? No. So both of those are out. Doesn't matter what kind of water, whether it's steam or cold or anything. The only thing these are going to do down here is they'll do a synthesis reaction. That's it. And then you can go down here, and you can see that silver, platinum, and gold, very unreactive. They don't even want to do a synthesis reaction. It says only form oxides indirectly. So that tells me it's a no, that these do not form a synthesis. Gold does not tarnish. All right? I have not cleaned this wedding ring in a long time. And I'm sure it has dirt on it, but it's not dirt from reacting with oxygen. It's dirt from my regular wear and tear of the ring. Okay? So that's kind of the rules. Something else we're going to add to this chart that's probably added in yours, we're going to add some decomposition rules. All right? And so the first decomposition rule is going to occur right here. Like I'm going to draw a line right here. And it's probably drawn in your textbook between chromium and iron. And so from chromium and up, these ones right here, no decomposition. No decomp. Why? Because from chromium up to lithium, they want to be in a compound. They do not want to be by themselves. You are not going to be walking around the back 40 and trip over a single solitary piece of sodium. No. You'll trip over sodium carbonate, you'll trip over sodium sulfate, you'll trip over compounds of sodium, but you're not going to trip over just a piece of sodium, all right? They do not want to decompose. They always want to be in a compound. So if somebody asks you, hey, will chromium sulfate decompose? The answer is no, that doesn't want to decompose, all right? All right, so for the next decomposition rule, let's go from iron. And let's go all the way down here. Let's go to copper. So we're going copper up, and we're going iron down. All right. These ones, they will decompose, yes, on the decomp, if we got some hydrogen gas. So between iron and copper, these will decompose when you heat them. Only if they have some hydrogen gas to kind of accept some of that compound. All right, we got one last group. You can probably guess what's going to happen. It's mercury on down. So we had no decomposition. We had, yeah, if we had some hydrogen. And then here, you see gold, platinum, silver, and mercury, they love being by themselves. So all you have to do is just add some heat. And yes, they will decompose. Decomposition reactions, a yes on that last four. Okay, this should be drawn in your book, and if it's kind of sloppy, you might clean it up. All right, so here's what we're going to do. That's the basics. Now what I'm going to do is I'm going to pull this worksheet back in here. I'm going to go ahead and move this I'm going to move some stuff around here. I'm going to slide this off. All right, I'm going to keep my activity series out. Why not? I mean, I don't have it memorized. Yeah, right. So here's what I'm going to do. I'm going to go through the first 6 that show up on your worksheet that I left you, and then I'm going to leave you the next, I don't know, however many there are. I don't have it in front of me. There's probably another 10 or something. I don't know. All right, so we're just going to go through, and we're going to predict whether or not these occur. So our first example, and this is on your worksheet, the first 6, you guys can do, and by the way, I numbered them, and I went back in. They're A through F. All right, I just was copying, and I was copying fast. So, all right, so we want to ask the question, will zinc react with water? All right, so this is a single replacement. One thing you have to be able to do is you have to kind of identify what kind of reaction is going to occur. That way you can apply the appropriate rules, right? I mean, if I know single replacement, synthesis, and decomposition, I can kind of apply these rules. So, will zinc react with water? Well, if I go over to my activity series, here, I'll pull it back in. If I go over to my activity series, I'm going to find zinc. Zinc, 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 zinc. Here's zinc right here. All right, zinc reacts with steam. Well, that's a problem. Do we have steam? No. It says L for liquid. So here's what I'm going to say. I'm going to say no. Must be steam. Or we could say does not react with cold water. All right. Any way you want to write that. So hey, this one's done. Let's go to the next one. Tin plus oxygen. All right. So let me get my activity series back out over here. This is a synthesis reaction, and so I want to know if it's gonna form an oxide. So let me find tin. Tin. Did I miss it? Where's it at? Tin. Right here. All right. Reacts with oxygen, forming oxides. That's a yes. All right. So this is going to add together. I don't know what it is in your worksheet. Let's just say it's tin-4. So now we're going to balance this equation. It's a yes. We don't have to say yes. Yes is going to be us writing and balancing the equation. So it is going to be tin-4 oxide. Let's see, tin-4, 4. So if I have a 4 plus, and then we have oxygen, which is a 2 minus, we're going to crisscross those. So we'd have a 2 here and a 4 here. So SNO2. Let me work that out for you just so you can get more practice on seeing it done. I would crisscross, the 2 would go here, the 4 would go here, and then I simplified it like that. And this is already balanced. I'm not really concerned about descriptors here, so yeah. Okay, all right, so let me start working on these other 4 now. Let's go to this next one. Calcium and lead nitrate. So here's what we're asking. This is just a simple single replacement. We are asking the question, will calcium displace lead? Right? We're not worried about calcium and nitrate because remember, like has to bump like. That's what we kind of did when we did single replacement reactions. So will calcium bump lead? So we go to our activity series over here. And so when we look on our activity series, we are finding calcium. It's right here. And then we want to find lead. It's right here. And the rule is anything above is going to displace anything below. So calcium's above, lead's below, it's gone. We will have a reaction. So what we'll have is we're going to have lead gets bumped out, and instead we're going to have calcium nitrate. Calcium's a 2 plus, nitrate's a 1 minus, crisscross. Oh, by the way, I caught this mistake on your worksheet. It said it's lead 2 nitrate, so that formula was wrong. Haha, Mr. Foster, you're not going to catch me. All right, so, crap, that looks balanced. Yay, it is. All right, let's go to the next one. We have copper and HCl. You have to be able to recognize acids. If you don't know your acids, you are in trouble. So our question is, will copper react with an acid, replacing hydrogen? So we go to our activity series. I'm going to pull it back in here. And let's find copper right here. Do you see anything in here about reacting with acids? I do not. So guess what we say? No. Will not react with acids. Brownie face. All right, we'll go to the next one, E. E is asking, we have nickel oxide plus hydrogen gas plus heat. Now this kind of makes me raise my eyebrows. Like, what the crap's going on? Is this a single replacement? Is hydrogen going to come over here, bump out nickel, or we're going to have something weird over here? But when I see this heat, this addition of heat, I think the question is, are they trying to decompose nickel oxide? Because we have the addition of hydrogen and the addition of heat, and that's kind of a dead giveaway for is this going to decompose? This is going to go through a decomposition reaction. So we're going to find nickel. We're going to find nickel on our chart. All right, nickel, 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 nickel. Nickel's right here. All right, and we wrote out to the side what? Yes, decomposition if hydrogen's in. Oh, guess what? We got hydrogen. So this is going to decompose. So now what we have is we have nickel and some water. Boom. And it's balanced. Yay. Last one, chromium and water. Does chromium react with water? Let's find chromium. Chromium, 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 chromium. Chromium's right here. Reacts with steam, but not cold water. Oh, man. Oh, too bad. It's cold water. No. Will not react with cold water. Come on, guys. Everybody knows that. All right. That's how you do activity series, okay? Yeah? All right. Me back. Here I am. Hey. Now, here's the deal. You have done a worksheet for me, all right? And this is another worksheet. So what's going to happen is, hopefully we're back together Tuesday, but if this stupid old man winter stuff keeps going, what we're going to do on Tuesday is we're going to get together and we're going to kind of talk about our worksheets. So I'm gonna have a Zoom time for us on Tuesday. All right. If we have the snow that they're talking about and we're not here, I'm gonna have a Zoom time with you guys. All right. So be sure that you got some good internet. If you don't, make sure you have some good internet. And what we're going to do is we're going to go through, get some feedback on our one worksheet where you guys had to do the 5 types of reactions. We're going to go through and get some feedback, and then we're going to get some feedback on this reaction sheet, okay? All right? Hey, I hope you guys stay safe. I hope this is going to make some sense for you. In the meantime, bye.